Okay, so introduction to general chemistry. Emphasize the general chemistry, which is kind of, general means kind of all-encompassing, versus organic chemistry versus physical chemistry versus analytical chemistry. So when we talk about the field of chemistry, in general, chemistry is looking at elements and what would we be without our periodic table. So we'll be talking more about the periodic table, and some of you guys know each box represents a different element. So chemistry is looking at elements and how atoms of elements join together to make in a repeating unit, to make either to make a compound. Okay. You might have learned this coming through your science classes, K through 12, that all matter has mass and occupies space. Sometimes it's odd to think that the air has mass, but it definitely has mass. Okay. All matter is made up of atoms, and all matter has mass and occupies space. And if I go too fast, I'll fill in the blanks. So we have a lot in our textbook. We have a lot of figures like this. I'm going to show you a figure with a scanning electron microscope coming up, where we are kind of trying to look a little bit more at kind of individual atoms or molecules. This is just a figure. And in my mind, I dream of the, all matter is made of atoms. There's some atoms. This happens to be a substance we call pure substance because all the atoms are the same, aluminum atoms. All cute stuff together. Okay. We compare that to these molecules in this bottle of ethanol. Okay. So they have repeating units here. Carbon are the black little things. Okay, the white little things are hydrogen, and that little red thing is oxygen. To kind of show you the repeating unit of an isopropanol molecule. So this is a closer up view. This isn't a figure. This actually is a photograph. We don't have one of these on hand, but this would be a scanning tunneling microscope to try to get a sense of the atom. Atoms are very hard to see. They're very small, okay? And then the fact that they are so small means that the way they interact with light, visible light, is difficult. You might kind of recognize a little helix structure here. Okay, so these would be back to, this is what we call a molecule, a macromolecule. It's macro meaning humongous. So this is a DNA strand. Don't have one of those. Oh, that's the same device. So I actually got a prop for this one. Hold that out. Since the weather's cold. Oh. Mother Nature. All right. So we can't see the water molecules, but what's the formula for a water molecule? H2O. Exactly. We can't see them, but there's basically an oxygen, hydrogen, and it has this kind of cool shape to it. It's not a line like this, it's bent. Okay, but we know we have those particles, those molecules. Here we have it in the same order. This is water, it has. This is water, liquid. And this is water, solid. Okay. So do you think there's water gas in here? When what's the most abundant gas? What's the most gas? Not oxygen. Nitrogen. Yeah. It's like about 80 nitrogen, 20 oxygen. But there is a certain amount of water in there. Yep. But in the wintertime, we run humidifiers because we want to humidify the air. So I just put a lid over there. If I could put a foil on, yeah, I got some H2O gas particles in there. This is water in its vapor stage, water in its liquid stage, water in its solid stage. We could talk in general about how those cute little molecules and water molecules are. So over here, they're not really lined up as an ice cube because lined up as a snowflake, you have that kind of hexagonal thing sort of going. This would be an ice cube. So anyway, but the snow, I would say that these water particles are, see how rigid this is? They're stuck together. They're stiff. And the reason they're stiff is because they have a lot of what we call intermolecular bonds. Now I can pick this up, but I can't pick this up, right? Okay, definitely can't pick that. So with this liquid, we have the liquid water molecules are stuck together some. They are stuck together some, because you can kind of see they're stuck together some. As I lift up my hand, I have kind of droplets. So you can kind of see that they are stuck together some. But I can pass my hand through it versus I can't pass my hand through this. So these are all stuck together, and these are just stuck together some. Okay. Now if I go over here, these are like not stuck together at all. I love gases. Gases are awesome. And I kind of, which came first, the chicken or the egg? I don't know if you can tell, but can you see on this, can you see this is trying to show motion? Gas particles are awesome because they're just, okay? So it's almost like they're just got too much motion to stick together. Or do they not? Wait, they got too much motion to stick together, or do they not stick together just because they have too much motion? Anyway. So that's kind of what they have going. Now, this matrix, I don't know, do you have these all to fill in and such? The description goes like this. The solid has a definite size and definite shape. Wait, definite size and definite shape. The size is volume, so definite volume or definite size and definite shape. Okay, now this one, I could take, oh, sorry, we're going across. The degree of bonding is high, the kinetic energy is low. They're kind of like, well, we have a bearded dragon, and our bearded dragon eats phoenix worms. And so my husband orders phoenix worms, and they come in, and when it's cold these days, you get the phoenix worms, and they're just like barely moving. So ants when they're cold, worms when they're cold, are just barely moving. So I kind of think of that. Okay, basically something in its solid state. All matter has motion, but it's not moving as much. Okay. Now, if we compare that to liquid, am I going liquid or gas? Okay. Liquid, by golly, this volume is, and we'll talk about this a little bit tomorrow, but I don't know if you can see these numbers on the side. This is called a beaker. These numbers on the side of the beaker is 400, and the units would be 400 milliliters. So, by golly, that's 400 milliliters. But I could take this and pour it into a tall piece of glassware called a graduated cylinder, and it would take on the shape of the container. I think that's pretty cool too. But it'd still be 400 milliliters. So for that reason, we say that its size or its volume is set 400 milliliters, but its shape takes on the shape of the container. So these next two we say are moderate. Okay. How much bonding do we have between those water molecules? Some. Intermediate. How much energy do they have? Well, if I were to be able to, and there's ways to do this, to isolate one of these molecules and isolate one of these molecules, this one would have less energy, less kinetic energy. Kinetic means energy associated with motion. Less motion, this would have more motion. Okay? That's what it is. The last one, wow. You know, anymore that you go into restaurants and bars, I guess, and you can't smoke in there anymore. Well, I don't know how I feel about that, because I have family members that, you know, that's a hard thing. If you want to stop smoking, okay. But my point about that is smoke in gaseous state, it's going to basically go wherever it can. It's going to take on the volume that it can. Okay, you take a certain amount of cigarette smoke, then you open up the container, and it's going to diffuse. The word is diffuse, right? So it's going to take on the volume. Okay, so its size or volume is indefinite, and its shape is also indefinite. I've heard it likened, so the whole idea of having a non-smoking section, you're like, oh, really? Yeah, the Perkins there in Burlington used to have a non-smoking section. You're like, oh, that didn't work very well because you know how it goes. It's like being in a swimming pool and having a non-peeing section. Okay, or you have little kids in the pee section. Like, it's kind of different. You just, when you go swimming, you got to count on that. So what would you say about the intermolecular bonding? Low, very low. In fact, I think I say none. If it's ideal, which the more you pressurize a gas, the more you are likely to go ahead and get some gases to bond to each other. But none. So what would you say about the kinetic energy? High. Exactly. Exactly. So those are one of the things I like about science is there are some things where you're like, oh, that makes sense. You just like, yeah, I get that. And I bet you get that. Okay. So what we've been talking about is these molecules being stuck together, a molecule being stuck with another molecule called intermolecular bonds. Sometimes they're called intermolecular forces. Must have taken out a lot of words on that one. Okay, so let's take a look at this little video.